session called memory management. Okay. Okay. So guys, how are you doing? Everyone okay? Okay. So what is memory management? This is what we are going to discuss today. Memory management, just let me mute myself so that I will not get disturbed. Okay. Yeah. Okay. So what we are going to study or learn today, what we will learn is mainly this is not the complete memory management in Java, first of all. Mainly, we will learn that particular part which will help us in debugging our code. That is the most important skill for a developer. Like, if you are a developer, then you should definitely have that skill of debugging. And in the debugging, this particular topic, memory management, will help. So why we are studying this now? Because now we are going deep inside the DSA, data structures and algorithm. Now, like the questions which were previously discussed of arrays or strings, those were very simple ones. Okay. So in those questions, yeah, you need the skill of debugging. I don't say no. But from now onwards, the question will be of type medium and hard. So that's why it will be more important so that you can trace your code. You can do the functional tracing of your code. So, what we will learn today, guys, what we will learn today, we will basically learn to understand the flow of the code. Whatever we write, how the code flows in the memory. We will understand that. Okay, okay. So, how we will learn? So we will learn with some examples. Okay, let me, yeah. Okay, so let's take the first example of today. So example one. What is example one? In example one, suppose we have a main function, and why these are written up here, this will be needed in later uh, part of the session. Okay, so what is the first problem? So let's think like we have a main, okay, and in that main we have int x is equal to 10 and int y is equal to 20. Okay, we have int x, we have int y, we have int temp 1. Let's suppose it as add, and in that add we are passing x and y. Okay, okay, understood. And now we have a temp 2. Now we have temp 2. So in that temp2, what we are doing? Just let me, yeah. We have suppose int temp2, and in that temp2 we have something called multiply. Multiply. Why things are getting popped up? We have something called multiply function, and in that we are using temp1. In that we are using temp1 and suppose a 30. Okay, okay. And after that we have int temp3. So these codes we have already written. This is very simple. You don't have to uh, explain this again. We understand this, Akash. We understand this. You don't have to explain it again. Okay, I'm not explaining the code. What I am doing is, what I am doing is, I want to understand that, do you guys understand how the code flow happens? So now we are trying to uh, print a temp3. So we have something like this. Why we have changed the color, I don't know. Can you guys tell me the, just let me make it uniform. Yeah, sounds cool. Okay. Can you guys tell me the value of temp3? Can you guys tell me the value of temp3? Yeah, hello guys. Hello, Toxic Toad. Hello everyone. Hello Hussein. Yeah. Okay. So how we can do the tracing? How we can do the tracing? So what we are trying to do, this is called function. This is called function call tracing. What in Why this is used? Why this is used? This is used to basically understand the flow. Okay. So what happens is, guys, like you must have heard about stack. Before going to that, let's discuss one thing. You must have heard about stack. So what is a stack, guys? Can you tell me? What is a stack? What is a stack? So what is a stack? Stack is a stack is a data structure. It is a data structure. Uh, Sir, but you have not uh, taught us this stack. Yeah, that's okay. That's okay. So something like this is called stack. Something like this is called stack. So you guys must have seen some, like, okay, I'm not very good at drawing, but let's try to make it okay. So in parties and all, you must have seen plates kept in this manner, right? So this is a classical example of stack. This is a classical example of stack. So, so, so what is a stack? In stack, we can keep our data. If we will talk in terms of data structure, so in stack, we can keep our data one by one. And as you keep the plates one upon another, so from where you take the plate out, if you want to take a plate out of that particular stack, so from where you will get that? You will get that from the top of it. You will get that from the top of it. Like, you're not going to pull the plate which is in the bottom, right? So this stack follows a property called last in, first out. This last in, first out, LIFO. You must have heard about this term LIFO already. Last in, first out. So what happens? What happens? Like, whatever will come in the last, it will go outside first. Whatever will come in the last, it will go outside first. Okay. So why we are discussing stack here? Why we are discussing stack here? Because, guys, because whenever any function execution happens, this happens in a call stack. Please remember this name. This happens in a call stack. So suppose this is a call stack for this function, and this happens in a call stack. Okay, understood, understood. So this is what this is called. This is called call stack. This is called call stack. And one more thing, guys, which I have already told you, you have to be very focused today. You guys have to be very focused today because this class will impact all the upcoming classes. Okay, because if you will not know how to debug a code, how to trace back to the function, or how to trace into a function, so it will be very difficult to point out your mistakes which you are making during coding. So you have to be very uh, focused. So one more point I want to write is execution of a execution of a code always start from, I have already told this, but I am telling it again. Always start from main function. It always starts from main function, right? This we have already discussed. Okay. So what will happen this call stack? What will happen? A stack will be created. A stack will be created with the name of that particular function. So the name of that particular function is main. Okay. So a stack is created, and in the main, it will go inside. It will go. Okay. It saw one variable. So it will initialize a variable with some value 10. Okay, done. It will go. Again, it will see one variable. So again, it will initialize some variable with some value 20. So what is this happening? Here, some memory locations will be getting created like this. Okay. Okay. Something like this will be happening. And we have a information in this stack. Okay. So now this is done. This is done. Again, go. When we will come here, guys, it's the most important point. Okay. When we will come here, now what we will create a temp variable. We will create a temp variable called temp1. And in that temp1, what we have? We are calling a function add. We are calling a function add. So, okay, we cannot create it here. Like, how should we do it? Just a second. Just give me a second. Hmm. How to? I have to take it out. Okay, that's okay. So we can do this on the right? Okay. Yeah. We can do it here. Mm, let's take this uh, little bit on the right side. Hmm. Okay. Now we have some space. We have some space. Okay. So now what will happen? Now what will happen? Yeah, little bit on the left. Okay, great. Now what will happen? We have that x is equal to 10, y is equal to 20. For temp1, we are calling a function. We are calling a function. Since we are calling a function here, again another stack will be created for that particular function. So again another stack is going to be created. So for that function add, another stack is created. But what we will do in that add function, sir? In that add function, what we will do? Okay, we will have some functions add, multiply, and subtract here. Wait, okay. Did some mistake. Let's wait a second. Yeah. Mm, mm. Let's bring it down. Understood. So in this add, this is the main function. This will end here. Okay. See how we can think of that. This is starting from here. And Just a second. Hmm. From here to here, we are doing that main function, okay? And after that, we will have add, multiply, subtract. After that, we will have a add function, right? Add. And in that add, what we will get? Uh, yeah, hi guys, hi everyone. In that add, what we will get? We will have int x, comma int y, and in that we will have a return x plus y, right? Right? So this is add function from here to here. And after that we will have a multiply, a multiply function. Again, it will take some values as int x and int y, and this will return x into y, right? Right? So this is another function. And after that, we will have one function called subtract, and this will again take int x and int y, and this will return x minus y. Okay, understood, understood. So for this add function, please pay attention. Please pay attention. For this add function, we are creating another stack, and in that particular stack, we will start from here. So here we are creating two variables, x and y, and these x and y are coming from this x and y are coming from here. We are passing 10 and we are passing 20, and these 10 and 20 are getting stored here in x and y like this. Tell me one very important thing, that are these x and these x same? Can you guys tell me that? Can you guys tell me that? Are they same? This question I will not answer as of now. I will tell it later. So in that now we are getting x is equal to 10, y is equal to 20, and we have to return x plus y. So this is 30. So we will return 30 here. Understood, understood. So now the work of this function is done. The work of this function is done. So what will happen? This particular stack, okay, let's not make it with this color. This particular stack will get, will come out of the call stack. This particular stack will come out of the stack. It means it will get removed because its work is done. Its work is done. Now, now see, now if it is done, we will come back to here. In main, we were in line this, and now we will again start. Okay. Now we will go to temp 2. Now we will go to temp 2, right? Okay, I have to make it little large on, okay. Mm, let's make this like this. Change the shape. Okay, great. Mix it. System. Yeah, great. So now the now the control came again into the now the control came again into the main function. Now we are trying to find temp2. Now we are trying to find temp2. So if we are trying to find temp2, so again this will happen, guys. Now we can speed up, right? In temp2, we are trying to find this function. So again another call stack will be created. And again another call stack will be created. and that call stack will have a multiply. The name of that call stack will be this one. And here we are passing temp1, and temp1 is 30. So here we are passing 30, and we are passing 30 here, and this is getting stored in here. So here again we will have x is equal to 30 and y is equal to 30, and we will return x into y. So we will return it as 900 since all the work of this function is done. So again this particular stack will get removed. Again this particular stack will get removed, and since this is done, so again the control will come here. Now from temp2 we will again go to the next line. In temp3, what we have again another function. And what is that function? This is that function, right? In this one, what we will do? And this one we will have temp2. So temp2 is 900 and the second value is 5. So x will be 900 and y will be 5, and x minus y we have to return, right? X minus y we have to return. Here, see, here we have to return x minus y. Okay, return we have not written. Okay, return x minus y. So once we will return that x minus y, again this one will get wiped off. This particular stack will get wiped off, and we will store some value temp3 as what? As what? 895. Done. Now we will print SOPLN. So after that, we will print the output here. We will print the output here. So the output will be 895. And once the whole work is done, so again the stack which is hold by the main function, this will also get wiped off. This will also get wiped off. This was simple. This was simple. This was simple. But this is not, guys. This is not. Honestly, this is not that simple. We have done a single problem, and it took us something around 20 minutes. Now, from the next problems, what we will do? We will do it little fast, and you have to respond. You guys have to respond. So let's go to the next problem. Let's go to the next problem. Everyone understood this, right? So what we have done? For when we go to a function, see, here, when there is a function called done, another stack got created. Work of that stack done, then the value got updated. After the value got updated, this stack got wiped off. Again go to this. Again another stack got created for multiplication. Again we got some value for that. This got wiped off. Again another stack got created. Again it returned some value. And after that this got wiped off. Again we printed that value here. After that this also got wiped off. Okay, understood. This was simple. Let's make it clear because it will be needed later, right? Yeah. Okay, understood. Let's go to the next problem. Hmm. So what is the next problem? So the next problem is, again, we have a main function. In that we have int x is equal to 10, int y is equal to uh, 2. Okay, int x is equal to 10, y is equal to 2. And after that, we have same int temp 1 is equal to add, sorry, like that, something like this. Okay, and after that, we have int temp 2 is equal to, we have again the same function, we have a temp 1 comma 10. Again we have the same function, int temp 3 is equal to add. In that we have temp 2 comma 22. After that we have to do sopln uh, temp 3. Simple. And we have the add function. It will take int x, it will take int y, and after that it will return x plus y, like this. Let's make the call stack for this. Let's make it little fast. Yeah, we can manage here, right? Mm, this much is okay. Okay. So initially x is equal to 10. Let's do it fast. This is for main, right? X is equal to 10. After that, y is equal to, okay, there it will need two actually. Wait. Yeah. Hmm. So it is x is equal to 10, and second one is y is equal to 2, right? And in the third line, this is done. In the third line, when we came for a temp 1, the third line, when we came for temp 1, what happened? It called a function. So when it called a function, the name of the function was add. So in that we are passing x and y, which is 10 and 2. So this 10 and 2 came here. Mhm. Hmm. That's okay. Yeah, this 10 and 2 came here. So now the x and y in this stack, the x and y value in this stack is it is 10 and it is 2. It added the sum. It came as 12. And once this is done, so this particular stack got wiped off. So once this is done, we got the temp 1 value. Now again we go to temp 2. And in temp 2, again we are calling the same function. So for this, again we will create a stack with the same name. This is what I want to show you guys. And this time we will pass temp 1. So this time we will pass temp 1, that is 12. So this time x will be 12 and y will be 10. So temp 2 will be 12 plus 10, it will be 22, right? And this will be again got wiped off. Right? Okay. And now we will go from here to here. Again, we will have temp 3. And in that temp 3, similarly, we will have something like 22 plus 22, that will be 44. And we will here have x is equal to 22, y is equal to 22, and the name of the stack will be add again, because we are calling the same function again and again, guys. So we are creating stack with the same name. And after that we will give this value as 44. And once this is done, so what we will do? We will wipe this particular stack as well. Understood, understood, understood. So why you are giving so much focus on these things? What is the reason behind that? The reason behind this is you will now understand. You will now understand. Just after giving you some theory, I will tell you why we are focusing so much on this. Okay. So now what we will study? Now what we will study? We will study memory management in Java. Memory management in Java. Suppose we have a function like main example. We have a function called main, and in that we have two variables. Okay, we have int a is equal to 10, and after that we have int. mm, let's make this value as of size 2 or something. Let's make it of size 2 or something. So if you will create the stack, call stack basically for this particular function, what will happen? What will happen? I will tell you. I will tell you. This is very, very interesting, guys. This is very interesting. So if we are going to create a call stack for this one, if we are going to create a call stack for this one, so what will happen? Suppose this is the main. This is the main. This is the main. Let's this is the main. Let's change the color, okay? Because it will match. Yeah, this is the main. In main, this will be simply done, right? This will be a is equal to 10. Okay, okay. But when we will come here, this is very important. This is very important. Like if we try to create a array with size 2, it doesn't get created here in the stack. We have something called heap. We have something called heap. In memory, in memory, we have two things. Like memory are of basically two types, I should say. We will discuss it later. Don't put so much stress on that. Just hear it out. We have something called heap and we have something called stack. So stack, which is already we were discussing, and we have something called heap as well. So when we create an array, this gets stored in a heap. This gets stored in a heap, not in the stack. Okay. So we will create a array which is of size. What is size? Okay, it is the size 2. So it will be like this, and initially it will be 0 0. But how we will store? We have to have a we have to have a reference of that in our stack, right? So how we will store that? We store the starting memory location of that particular array. I am repeating it again. What we store in the stack, we store the starting memory location of that particular array. So suppose the starting memory location of the array is 4K. So we will store something like in A, we will store 4K. I know you guys have not done that previously. Like if you will do SOP, like okay, if you will do SOP A here, so you will get some value like a hexadecimal value, like something like A492, something like this. So what is that, guys? This is basically this memory location. This is that memory location, the starting memory location of that array. Okay? Okay. Understood. Understood. So let's leave it. Yeah. So if you have told us this thing, if you have told us this thing, so can we say that we can we can we can access a variable, or we can say basically variables are of two types first. Okay, first one is the primitive one. The first one is the primitive one, and the second one is the reference variables. Like to get the data of the out of that particular variable, we use the reference. So in primitive, what we have? We have int, we have long, we have double, float, everything, char, boolean. Like what we have? Int, long, boolean, double, float, char, etc. etc. Right? Right? Okay. So if we want to store a primitive variable, then it will be stored in the stack. And if it is something of kind reference, like in array, what happened, guys? See, I'm not going in much detail as of now because there are some limitations. I cannot tell you everything as of now because there are some limitations. You will not understand. Just so what we are storing here, we are storing the reference of that array, the reference of that array. So if we want to get the data out of that array, so we go to that reference and we get the data. We get the data, right? Right. Okay. Okay. So we are storing the reference. That's done. That's done. Understood. Understood. So if you have understood, so can we say one thing? Whenever we create a whenever we create anything whenever we create anything using new keyword, memory gets allocated in heap. Whenever we whenever we create anything using a new keyword, it gets its memory in heap. We can say that, as you have done that, right? As you have done the similar thing here, right? Okay. It's wrongly written, guys. It's wrongly written. Just let's make it little right. uh, Int, this is the array, this is the name, is equal to new int. So whenever we have in this line, whenever we create a variable using the new keyword, it gets its memory location in the heap. We can write that. Whenever we create a variable using new keyword, what is keyboard, new keyword, this is the important word, new. This has to be circled. New keyword, it gets memory in heap. But why this happens? Why this happens? This happens because I have written something on the top. See, this using a new keyword, what happens is one object is created. When we use the new keyword, one object is created, and objects get its memory in heaps. And whenever we have classes, those classes get the memory in stack. But Akash, you have not told us what is a object and what is a class. Don't worry, the next class, the next day, most probably something around 2 or 3 in the afternoon, we will discuss what are objects and classes. So please don't forget to attend that as well, because you will understand this more nicely. Okay, so if we have, so why, now we understand that why if we use a new keyword, why that gives, why that gets the memory location in heap, because this creates a object, and that object always gets its memory location in heap. That is the reason. That is the reason, guys. That is the reason. Okay. I don't know. The name is very complex, but that's okay. Okay. So this we understood. This we understood. So if we will, suppose we have something like this. Let's go to another example. Let's go to another example. Suppose if we have something like this, we have a main. In that main, we have a int x is equal to 2, int y is equal to 3. That's okay. It's upon me what value I want to give. And we can have int, let's take a, and let's take the size as new int, the size be 4. Okay. And let's take now b, and this will be a two-dimensional array. Okay. And the size of that, make the size of that like it will be 2 comma 3. Okay. So in this case, what will happen? In this case, guys, what will happen? So in this case, suppose if we have a call stack, if we have a call stack here, suppose this is the call stack, guys. So what will happen? In the call stack, suppose this is the main stack. So in the main stack, x will simply get the value 2, y will simply get the value 3. But for this, we will create one array with size 4. This will contain 0 at all the places. Suppose the starting memory location is 4k, so we will store that 4k in here. And again, for b, suppose it is 2 by 3 matrix, right? So 2 by 3 means 2 rows, 3 columns. Okay, so it will be something like this. Okay. 0 0 0 0 0 0, and its starting address is 8k. So we will store 8k here. So and one more thing, guys, one more thing, that this is this is pointing to this thing. This is pointing to this memory location. This is reference, and these are primitive data types, normal integers, right? Understood. Now we are getting the clear picture. Okay, let's do some quiz. Like, I will write the question on the board, and what you have to do is you have to think. After that, I will explain what will be the correct answer. Okay? Okay, so let's. Okay, so yeah, we have, suppose the function void change, and what we have to like think is, like, there are no syntactical error or some error like that. It will work. Okay, we don't have to focus on any errors or something like that. Okay, and in that we have a is equal to 50, and in that, suppose this is closing, this is the change function, and now we have the main function. In the main function, what we have, suppose int a is equal to 10, int a is equal to 10, and let's call that function change with the value a. Let's call that function and let's do sopln. If we will do sopln with a, so you have to tell me what will the output. You have to tell me what will the output. Come on, guys, tell me what will be the output. What will be the output? Yeah. So what will the output, guys? Now let's focus. A is equal to 10. Okay. Now this is the main. This is the main. This is the change, right? In change, what we have? Again, we have A, and that A was initially, it was passing, it was passing as 10. So it will have initially 10, right? And now in this, we have changed the value from 10 to 50, right? Right? We have changed the value from 10 to 50. And now we are, okay, this is done. This is done. So this will get wiped off. This will get wiped off. And if this is get wiped off, now we will come into this line. So we will print A. So what we will print? What we will print? We will print, we will print 10 here. Why? Why? Because these are not same variables. These are different variables in different scopes. These are different variables in different scopes. You have to understand these, guys. You have to understand these. See, in this scope, we have a, which is this one. And in this scope, we have A, and which is this one. These are not same, right? Okay, now we have understood that. Okay, now we are getting. So if this question will be given to you, and by the way, this question is already asked in many OA exams, in many online assessments. This was like this was asked with many service-based companies, and many product-based companies also ask as MCQs. People will make mistake if you will not create that functional trace diagram. You will make mistake. Okay, okay, this time we made mistake, but that's okay. If you will give us the next question, we will not. Okay, let's see, guys, let's see. Suppose this is the question 2. In question 2, again we have suppose void. We have the same function. Let's make it easy for you, guys. We have the same function. We have int a, and that is an array. Okay, we have int a, that is an array. And at the 0th place, what we are doing in the 0th place, what we are doing, we are suppose changing the value from something to 50, something to 50. Okay, and let's close it. The function work is done. We will have a main function, and in that main function again we will have suppose the same yeah, like this. Okay, done, done. And after that we have, or we can do something like this directly. Wait, directly initialize it. Okay, we will have, why this is not getting initialized, we will have 1 comma 2. We will have 1 comma 2. Okay, if we have 1 comma 2, okay, okay, if we have 1 comma 2, and yeah, and now we will call that particular function change. Now we will call that particular function change with a, with a, and after that we will do sopln a of 0. Now you have to tell me the answer. Now you have to tell me the answer, guys. But please pay attention that this is not a simple problem. This is not a simple problem. You have to create this function trace diagram for that. You have to create this call stack, or else you will definitely make mistake. No, sir, we will not make mistake. So if that is the case, try. Okay, we are ready, guys. We are ready. Okay, so what we have? We have this main stack. In that main stack, we have one array. In the main stack, we have one array. Let's create that array here. And in that array, we have 1 and 2. And the starting memory location is 4K. So in here at A, we have stored 4K. Understood? Now now guys, focus. Now what we are passing? We are passing this memory location. We are passing this memory location. So what we got here? We got that memory location, right? So here we have a variable a, and both of these a are pointing to same memory location, guys. Both of these are pointing to same memory location. And in this a, now what we are doing? This is also pointing to 4K. And this a of 0, we are changing the value from whatever it is to 50. So we are changing this value and making it 50. So this value is changed and it turned out to be 50, right? Okay. So now this is done. This is done. If this is done, if this is done, so this will this will get deleted. We will come to the main stack. Done. Come here. Try to print a of 0. At a of 0, what we will get? At a of 0, we will get 50. Right? I know, guys, this was little complicated. This was little complicated, but you should be able to do it. If you will create this stack, this call stack, then you will not make mistake. Then you will definitely not make mistake. Okay. Okay, this time again we made mistake, but give us the next question. We will not do that. Give us the next question. We will not do that. Okay. If that is the case, guys, if that is the case, so let's go with the third one. Let's go with the third one. So this time we have a function called test, and in that test, what we are passing a, suppose, a array again. We are passing a array again, and in that we are using a is equal to new int, and we are changing the length. Okay, we are changing the length. Okay, we have created a new array basically, and at a of 0 now, we are changing the value to 50. This is the test function, and I'm again telling you guys, you don't have to worry about the syntactical or any errors. Okay, the you have to think that this is the correct code. Now here again we have a int a. We have something called, suppose, 10. Okay, let's have 10, and after that call that function with the value a, right? And after that, do sop ln a 0. Close it. Okay, come on, guys, try. Please, I'm again requesting you, before doing the problem, try to create the call stack. Before doing the problem, try to create the call stack. But yeah, it's visible. Okay. So now we have created the call stack. Okay. So we have one array. So this is simple. This is very simple. We will have a stack. We will name it as main, and we will have one array, and that array contains only one value, 10, and we will give some memory location to it, that is 2k, and we will store that memory location here. We will store that memory location here. Hi, Raghav. Hi, Raghav. We will store that memory location here. So if we have stored the memory location, that's okay. Now, now this line done, this line done. Now we will create another stack. This is the another stack. This is called test. And in that test, what we have? In that test, we are creating a variable. And since we are passing that, since we are passing that a here, so we are passing 2k. So initially the value of uh, a is 2k. Okay, okay. But now what we have done, guys, see, now what we have done, I have to change the color of this because or you guys will get confused. Just, hmm. I am using the same cursor on actually four screens, okay? So that's why I always forget where my cursor is currently. The same cursor I'm using at four screens, guys. So that is the reason. Okay, okay. So what we have? We have we are in this line. We are in this line now. So we are creating a new array. So we are creating a new array with same size 1. But if we are creating a new array, so the memory location, the starting memory location will be different, right? So it will be something like, suppose it will be 4 or 3k. Let's suppose it is 3k. So the starting memory location will be different. So when we have created that, so in this particular line, what will happen? This value will be changed to 3k. Okay. And at at 3k, at this particular memory location, at a of 0, we will change the value to 50. So see, guys, see, you have to pay so much attention now that this this one this one is not getting hampered. This one was pointing here, and this one is pointing here. When we are trying to change the value, 3k is in the heap since we use new keyword to create object in the heap. Yes, yes, yes. So so this value is not getting changed, right? So now if we'll go, this is done, this line is done, this is done. So what will happen now? What will happen now? This will this stack will get wiped off. Okay, I'm sorry, this got little messier. Hmm. So this stack will be get wiped off. This will be removed, and if this is removed, we will come back to the our main. We will come back to our main, and since we have came back to our main, in main we will come back to this line, and we will try to print a of 0. We will try to print a of 0. So at a of 0, at a of 0, what we have? We have 10. So this will print, this will print 10, guys. And now if you have done this question, I will tell you. I will tell you. This question was, let's make it little bolder. This question was asked in the OA of Amazon. So they don't want very fascinating things out of you. What they want is like, are you clear with your basics or not? Do you understand how the call tracing happens, how we trace our functions, how we do the debugging? Are you aware of that? Yes or no? Okay, okay, let's go to the next problem. Let's go to the next problem. And guys, if you have done the previous one, congratulations. You are one step closer to product based companies. You are one step closer to product based companies. And if you have not done that, if you are unable to complete that, that's okay. Another question coming up. Another question coming up. I am again requesting all of you that whenever you get these kind of problems, just try to create the stack as fast as you can, because it doesn't take so much time, right? It doesn't take so much time. So we have suppose a main function now. We have suppose a main function, and in that we have int a. This is the array, right? This is the array, and this has some values like 10, 20, 30. These are some values like 10, 20, 30. Okay. So, and let's call a function after that, fun a. Done, done. And after that, do SOPA. SOP. Let's not do, let's do like this because, yeah, that's correct. Done, done. And after that, we have to create that function as well, right? And in that, we will pass an integer value. Let's suppose we are passing with the same name. We are passing with the same name. And in that function, let's again do a is equal to new int a new array. Okay, and after that let's have at a of 0, let's change the value. Let's change the value to 100. Again, you don't have to think that there is any error or something. You just have to focus on the problem. You just have to focus on the problem. Okay, guys, come on, come on, come on, guys. Still, I'm giving you some time so that you can think of it. Okay. Or suppose if you're watching the recording, guys, there is a very humble request. Don't just go and watch the recordings. Like if I've written the question, just pause there and try to create the call stack by yourself. And after that, try to match it with mine. Like, are they same? If yes, then you are understanding the things. If yes, then you are on the correct path. Okay, okay. Let's do this. Let's do this. Let's do this. So we have again a array. वाह क्या करवा रहे हो sir? Same question. Same question. Same question है sir. Completely same. Nothing different. Size should be defined in the function, right? Like a is equal to new int 3. Uh, Size should be defined in the function. Like where you are telling? Oh, I'm so sorry, guys. I'm so sorry. Okay. We will have some size, right? Yeah. Okay. Yeah. Thank you. Very nice, Raghav. Yeah, that's obvious. We will have some size. That was a mistake. Okay. So now what we have, guys? Now what we have? We have one array. Suppose we have this array. Let's change the color because it will create problem. We have this array. In this array, this array has three spaces, and this has 10, 20, 30. And the starting memory location is suppose 4K. The starting memory location is 4K. Understood. And now, as we have already discussed, that 4K will be stored here. It means that it is pointing to this memory location. It is pointing to that particular memory location. Okay. Okay. Now it's okay. Now we will call this function, this line done, this line. We will call this function. So if we will call this function, another stack will be created. Here we have main, here we have main, here we have a func, suppose, and in that func we are creating a new array. We are creating a new array with size 1. So what will happen? Now we will have another array with size 1, and the starting memory location will be something else. The starting memory location will be something else. Suppose it is 2k. So here, initially what will happen, guys? Initially what will happen? This 4k, this 4k will be passed where? Here. And this 4k will be stored in here, right? But but when this 4k will come here, and that will be stored in here, right? And when we will come into this line, then we are again creating a new array with size 1, with size 1. So new array with size 1 with new memory location. So this 4k will be updated, and this will become 2k. This will become 2k, right, guys? Right. And after that, this line done, and we will change the value of a of 0. Initially it will be 0, and we will change it to 100. This line also done, this line also done. If these two lines are done, so what we do, guys? Tell me. We wipe that particular function. Wiped. Done. Now we will go back to the main function. We will come here. So we will try to print SOP A of 0. This A is printing where? Sorry, this A is pointing where? This A is pointing here. So it will print A of 0. That means it will print 10. It will print 10. So this will finally print 10. Understood. Simple. Understood. Let's go ahead, guys. By the way, this question was also asked in some OA. I don't remember the company name. Just let me check. I can tell you. It's media.net. Guys, it's media.net. It's also a product-based company. So this was asked in that media.net. Let's go ahead. This is the question 4. Let's go to next question. So how much time is left? Okay, we will solve two more questions now. Uh, Two last but very fantastic problems. Okay, just let's take a rest of around 30 seconds. Okay, so second last problem of the day. Suppose we have a function called swap, okay? And in that swap, we are no, let's not take this one. Let's take what should I do? Let's take this one only. Okay, I will change the problem. That's okay. I will change the problem. We have int a, and we have int b. Okay. So what you are trying to do? You are trying to create a swap function, right, sir? Yeah, I'm trying to do that, guys. I'm trying to do that only. We have so temp. In that we will store a, and in a we will store b, and in b we will store temp. This is the logic. You have already told this. Okay. And now we will have the, okay, I'm sorry. Now we will have the, we have to change this, right. Now we will have the main function. In the main function, what we have? We have int a is equal to 10, and int b is equal to 20. Okay, we have this, and now we are calling that particular function swap with a and b. Okay, and after that, what you are trying to do? Uh, Try to do sopln a comma b. Okay, try to do this, guys. This is not a simple problem. Please, I have already warned you in the starting. This is not a simple problem. You have to pay so much attention to solve this one. You have to pay so much attention to solve this one. Okay, okay. Let's start. If you guys want to, I'm again repeating that. If you guys want to solve it by yourself, then please create the call stack, then only try to solve it. Or else you will definitely make a mistake. A is equal to 10 in the starting and B is equal to 20. B is equal to 20. Understood? This line done. Now we will call the swap function. This is main. This is main. This is swap. This we have already understood, sir. And we are passing 10 and 20. So we are passing 10 and we are passing 20. This we are getting here, right? So here initially A is equal to 10 and B is equal to 20. Understood? And we have temp. In temp we are storing A. In temp we are storing A, right? Okay. Uh, So A value was 10, so we stored 10. Now in A, we are storing B. So this 20 is getting stored in this one. So, okay, let's change it. This changed from 10 to 20. And in B, we are storing temp. So this changed from 20 to 10. So we did the swapping. This all lines done. These all lines done. Okay, no problem. If these lines are done, then what we will do? Then what we will do? We will the control will come to the main function, and this particular stack will get wiped off, right? So when the control came to the main stack, this line is done, this is done. We will try to print sopln a and b. If we will try to print sopln a and b, here no impact is done on A and B. Whatever changes are done was done in the swap stack. And those changes we have not brought here. We have to return. That's why, guys, that's why when we had studied functions, we had to return whatever values we want in our main function. Now you can correlate those things, like why we were returning from our functions to the main function, and when we return we try to store that particular value in some variable here, right? Now you can connect all those dots. You guys were asking, can you tell us this? At that time I had told you, please wait, we will study it later. So now what we are doing, see here, the problem is we did the swapping, but that swapping is not getting reflected here. That swapping is not getting reflected here because we have not returned those swapped values to the main function. So the final output here will again come as 10 and 20 only. Okay, okay, okay. Nice problem, nice problem, nice problem. Very nice problem. So, have you understood this? Have you understood the why we use return in functions? And if we are not using that, what is happening? Whatever manipulations which we had done, we lost that. And once this will get printed, this call stack will also get wiped off. This call stack will also get wiped off. So if you have understood this, guys, this is the last problem of the day. And the best one, I can assure you the best one. This I have created myself actually. This I have created myself, like with some naughty tricks, but yeah, you will enjoy this problem. You will enjoy this problem. So what you have is again, yeah, let's have swap. In that swap, we will have suppose, and after that we have. So we are passing two arrays, Akash. We are passing two arrays. Okay. Now again, what we are doing is we have int temp is equal to a of 0. The value at a of 0, we are storing it in temp. And at a of 0, now we are putting the value which was at b of 0. And at b of 0, we are putting that temp. Okay, simple. Same thing you are doing. So same response we will get. You are doing the same thing, so we will get the same response, right? That's what we are thinking. That's what we are thinking. But let me complete the problem, guys. Where is my cursor? Again, I lost my cursor. You got it. Hmm. Okay, so, and in the main function, this is the main function, guys. This is the main function. In the main function, what we have is, in the main function, we have a int a is equal to, we have something called 9. And after that, we have int b, and we have something called, change it in the main. Why? Can you tell me the reason, Raghav? Can you tell me the reason? Can you tell me the reason for that? If you can tell me the reason, then I will understand that you have understood the whole class. Okay, so we have these values, and now we will call that particular function with with a and b, right? Yeah, with a. That's very good. That's very good. Can you explain that little? Can you explain that little so that other people can understand that? Can you explain that? Okay, so we are doing that, and after that we are SOP, and we have A of 0, and we have SOP, we have B of 0. Let's close that here. Okay, let's do the problem. The last problem of the day, guys, the last problem of the day. So have some patience. Have some patience. Just give me this line. Let's create a line here. Hmm. Okay. So we have two arrays. We have two arrays. One array is this one. Another array is this one. And one is called A and another is called B. And suppose the starting memory location is 4K for this and 2K for this. And the value here is, in A we have 9. In A we have 9. And in B we have 19. Okay, understood. So this is okay. And in A we are storing 2K, and in B we are storing 4K. Understood. We are calling the function. So from main, the control is going to the swap. In swap, what we are getting? We are getting A is equal to 2K. Focus, guys. Previously, what was happening? That previously what was happening? That we are creating another variable. But here, what is happening, guys? That we are not passing the values. We are passing the address. We are passing the address. We are not passing the Okay. Yeah, correct. Raghav, that's correct. Very good. And please remember this, Raghav, because in interviews, people do ask these. Okay. So here we are not passing the values. In the last problem, the problem was happening because we are passing the value and the value was getting changed in this stack, in this stack, in this stack. In this particular stack, the value was getting changed and which was not getting reflected here, right? But in current case, in current case, can we go little on the right side? Yeah, that's great. That's great. And can we take these to the right as well? Oh, I don't want to make it little, I want to make it little clear. That's why. Uh, so sorry. Yeah, cut. Okay, great. That's what I was wanting to do. Mhm. Now let's paste it here. Huh, understood. So now what is happening, guys? Now what is happening? We are passing the address. We are passing the address. So here in B, we are storing 4K. So now this A is pointing to, this A is pointing to, I'm not very good at drawing. I'm trying my best, but I'm not good at that. This A is pointing to this one, and this A is also pointing to this one only. This B is pointing to this. Let's change the color because it will make it more clearer. This B is pointing to this, and this B is also pointing to this. So, so if we will do any change, wait. We will not do it that way. We will follow the code. So what has happened as of now? We did this line. This line was done. We came into that swap stack. Okay. In A, we stored the memory location. In B, we stored the memory location. Done. Now we have another variable called temp. And in temp, what we are doing, we are storing the value which is at A of 0. So A of 0 means this is A, and this A is pointing to this value only. There is no another A. So if someone will ask you what is the advantage of using pass by reference, you can tell that now. You can tell that now, right? So we are changing the value from here only, and it will reflect here also. So now in temp we will store 9. Now this line is done. At A of 0 we will store B of 0. So at A of 0 means this one. B of 0 means this one. So 9 will be turned to 19 and 19 will be turned to 9. This line is done, right? Once this all is done, this will come out of this function. This call stack will end. This will be wiped off. And if this is wiped off, we will come to our main function. We will come here. We will try to print SOP A of 0. Okay. A of 0, A of 0. A will go. Okay. A will, okay. Where is A of 0? It is at 2K. Chuk chuk gadi. It will go. C. At A of 0, what we have? Okay, we have 19. So it will print 19. B of 0. Okay. It is at 4K. It will go. It will come here. It will see. Okay, it is 9. So now this time, when we are using the method of pass by reference, we are able to swap those. And why we are able to use that? Because in arrays, what we have? The arrays, the value of the arrays gets stored in heap, and we get a memory location out of it. Okay, understood, understood. Sir, is it possible to use pass by reference method to swap two numbers like in previous example? Also, explain how can we know if we are doing pass by value or by pass by reference? Uh, that you will understand, Raghav. Don't worry, that you will understand. Like once we will study classes and objects, and once we will deep dive into that. So see, in one class, it's definitely we cannot teach you everything, right? We cannot tell you everything. There are so many concepts. Okay, so this class was to be this class is planned today because I want to give some idea of tracing or debugging. Why why what is the motto behind that? The motto behind that is you should be able to debug your code. That's it. That is the motto of this class, memory management. But when this memory management will come in total fledge, like the we will go deep inside whatever questions you are asking, like how can we use pass by reference, and why we are using heap only, why we are not using stack for this, and how this is working behind the scenes. We cannot go into those details as of now. The reason behind that is, as of now we don't need that. Once we will complete the DSA to some extent, in some class between that, we will plan this memory management again, and we will discuss all these things in very, very detail. And yeah, you can ask me these offline, Raghav, don't worry. Okay. So we are done with today's session, guys. We are done. Okay. And okay, I try to remember these. Please like, if you have liked the video, what is that called? Share, and do subscribe the video, guys. Do subscribe, because from the analytics, what we saw is, like, suppose 400 people are watching the video today. If 400 people are watching the video today, so only 250 or 200 has subscribed it. Rest of the 200 or 150 have not subscribed the channel. So if you subscribe it, it's not much for you, but it gives us more confidence. If you like the video, if you share it, if so many people come into the class, it gives us more confidence. It boosts us up, right? Okay. Thank you. Thank you very much. Okay, guys. Done for the day. Thanks a lot. And yeah, one more thing, guys. One more thing. Now, what you have to do is, what is the homework? Okay. What is the homework? You have to implement all of these problems in the IDE. Then you will have the better understanding of these. Please try to implement all of these, and comment it, and put comment in the chat. Like, okay, done this thing, comment it in the chat. If you have written this code, comment it in the chat. So this will inspire other people, other folks as well. Okay, so these much people are uh, going with the class, so I should also continue with the session. We have to put ourselves together, and we have to go ahead. That's the motto, guys. That's the motto. Okay, done. Thank you. Bye bye. We will meet again tomorrow.